Here's some homework help for lesson 5-6, page 356. I've chosen 3 problems. Let's work through number 28, and we're ready, since the radicals are already on opposite sides of this equation, we're ready to raise both sides of this equation to the second power. And so when I do that on the left side, I get x minus 10. The effect here is just to remove the radical. Now on the right side, I've got to square this binomial, and we looked at an example like this in class. So let's just come down here, and once again we're just going to set this up to use FOIL. Multiply 1 minus the square root of x times itself. And when I go through the 4 parts of FOIL, 1 times 1 is 1. 1 times negative 1 times the square root of x is negative 1 times the square root of x. Same thing here on these inside terms. And then the last terms I get positive, negative times negative, and the square root of x times itself is just x. So when I combine like terms, I get 1 minus 2 times the square root of x plus x. And that's what will go on the right side of this equation, the result of squaring this binomial. Okay, so let's just erase our work here, give us a little bit of room. And now let's go about our business, solving for x. Well, trying to get the x variable that's not under the radical on the same side with subtraction means that these x's will just cancel each other. They wipe each other out. And so we're left with negative 10 is equal to 1 minus 2 times the square root of x. So I've got to work on getting x by itself. I'm going to start with subtracting 1 from both sides. Then I'm going to divide by negative 2, which makes positive 11 halves. And then to solve for x, I need to raise both sides to the second power. And 11 squared is 121 over 2 squared, which is 4. And I get what I think is a solution. But once again, you need to be careful, because sometimes they look like they're solutions, but when we test them, it turns out that they're actually not. So let's see if 121 over 4 actually works. So we'll just do a little check area here. And the square root of 121 over 4 minus, and let's just go ahead and change 10 into 40 over 4. Okay, that equals 1 minus the square root of 121 over 4. Okay, so under the radical, we get the square root of 81 over 4. And we're trying to see if that equals 1 minus, and we can go ahead and do the square root of this. That's square root of 121 is 11, and square root of 4 is 2. Okay, the square root of 81 over 4 is 9 over 2. And over here, when I do basically 2 over 2 minus 11 over 2, the right side is actually going to be negative 9 over 2. Well, obviously these two sides don't agree, they do not equal, so even though I came up with a solution, when I put it to the test, when I check it in the original, it doesn't make the left side equal the right side. So this is what's known as an extraneous solution. And so therefore, since 121 over 4 doesn't work, and that's the only possible solution we got, there is no real solution to this problem. And that is your answer for number 28. Okay, number 46. My first move is to multiply by 7 on both sides. And that's going to give me 14a raised to the 1/3 equals 7. And that's the same thing as the cube root of 14a. So I'm going to solve for a by first raising both sides to the 3rd power. And the effect here is to turn this into exponent 1, so it's going to be 14a to the first equals 7 cubed, and that's 343. Now it's pretty easy to solve for a with division by 14 on both sides. 343 divided by 14 is 24.5. And that is our solution for A. Now let's look at one more problem. I've chosen number 56, and the reason I chose this is because the solution here is different than the problems that I chose as examples in your notes in class. And so I wanted to show you this particular situation. From what I can see, it's the only problem of its type in your assignment, and I want you to be ready for when this situation comes. Alright, so as usual, we want to, with these radical inequalities, we want to take the radicand and pull it out and make it greater than equal to 0. Remember, we cannot allow this to be a negative number, so we're going to make sure that x isn't a number that would create this square root of a negative number situation. So solving for x, we get 3x is greater than equal to negative 9. X is greater than equal to negative 3. Okay, so that kind of gives us parameters for what possible or allowable values for x that they can be. Alright, so now let's go ahead and solve this radical inequality like we were doing earlier. So we're first going to add 9 to both sides, or add 2 to both sides to get 9. So adding 2 to both sides. Now we're going to square both sides just like we were doing earlier, and we get 3x plus 9 is less than 81. So 3x is less than 72. X is less than 24. Okay, so in this case, we did not have this situation earlier today. Now 24 is definitely larger than negative 3, so it meets the criteria that we came up with when we let the radicand be greater than equal to 0. However, we can't let x be any number less than 24 because the numbers, according to this, cannot be below negative 3 or less than negative 3. Okay, so once again, a little different way to write this. You can kind of see it. It's going to be all the numbers less than 24, but they have to also be greater than or equal to negative 3. Well, what we're really describing here is all the numbers in between. Okay, so we're going to have one of those between statements. X will be numbers between, and again, we'll have negative 3 on the low side, and then 24 on the high side, and then we just put these inequalities in between them. This is another way of saying x is greater than equal to negative 3. Okay, we just turned it around. When we write this between statement, we always put our variable in between the low number and the high number, and then this is just going to be less than 24. Okay, so again, I just wanted to alert you there's only one problem where the answer is written like this. In our cases, we had a number that was going to be greater than. So 24, in other words, is already greater than negative 3, so our answer is just all the numbers bigger than 24. At least that's the way it showed up in our notes in those types of problems. But in this case, it's the numbers less than 24, but you cannot go below negative 3 because that creates a negative under the radical, which is not allowed. Alright, so I just wanted to make sure I covered that with you. Again, there's only one problem that you will encounter on your homework, that works like that. So hope that helps, and if you have any questions, let me know.